Today we are going to look at logarithmic word problems. Now I apologize, mine does not look like yours. However, I have the problems on here. I just did not have enough space to do the work on the sheet that you guys have, so I wanted to do it on a blank sheet to have enough room. I'm going to complete numbers 1 through 6 with you. And then for your do now, please do numbers 7, 8, 9, 10, and 11. Those are the multiple choice problems. I need to see work done on numbers 7 and 11, but I do not need to see work done on 8, 9, and 10 because you can just look at the equation and come up with the answer there. Okay, so for number 1 though, as yours says, growth of a certain strain of bacteria is modeled by the equation G equals. G is the final number of bacteria, A is the initial number of bacteria, and T is the time in hours. And approximately how many hours will 4 bacteria first increase to 2,500? Round to the nearest hour. So I'm looking for time. So T is the only thing I should have left blank. G will end up being 2,500 because that's the final amount. My initial amount was 4 bacteria. So it's 4 times 2.7 to the 0.584 T. Now to solve this, I'm not going to multiply by 4 times 2.7. I'm going to divide by 4 instead. I'm not allowed to multiply because the 2.7 has a power to it. When I divide, I get 625 equals 2.7 to the 0.584 T. Because the base is a 2.7, I am going to take the log of both sides. I cannot find a common base, and the base is not an E. So you take log 625 equals, and then when you take the log of the right-hand side, you remember the exponent goes in front. So it's going to equal 0.584 T log 2.7. To solve for T, we divide by 0.584 log 2.7 on both sides. You end up getting T left over on the right-hand side. On the left-hand side, rounding to the nearest hour is 11 hours. And that's your answer there. Number 2 says, the Franklins inherited $3,500, which they want to invest for their child's future college expenses. They invest it at 8.25% with interest compounded monthly. Determine the value of the account in dollars after 5 years. Use the formula A equals. A is the value after a certain number of years. P is the principal invested, or the initial amount. R is the interest rate, and N is number of times compounded per year. So for this particular problem, it says I'm trying to find how much they're going to have in the account at the end. So I'm looking for an A. That means I should be able to plug in everything else. P is principal, so that's the amount I invest, or $3,500. R is the rate. The rate is 8.25%. As a decimal, it's 0.0825. Move that decimal 2 places to the left. N is number of times compounded a year. So in this case, it said it's compounded monthly. That's 12 times a year. And then the power is N times T. T is 5, N is 12. 12 times 5 is 60. All you do is you have to type the right-hand side in your calculator very carefully. And it's money, and it doesn't say exactly where to round, so we'll just do 2 decimal places so it's to the nearest cent. It ends up being $5,279.61. Okay, moving on to number 3 here. We have meteorologists can determine how long a storm lasts by using the function T of D, where D is the diameter of the storm in miles and T is the time in hours. If the storm lasts 4.75 hours, find the diameter to the nearest tenth of a mile. So I'm looking for diameter. I'm trying to solve for D. I should be able to fill in for T of D, which I can. It's 4.75. So 4.75 equals 0.07 D to the 3/2 power. To solve for D, I'm going to divide by 0.07. Okay, and I'm going to approximate here. I would leave everything in my calculator, but to 4 decimal places, it's about 6.7857 equals d to the 3 halves. Now I could use logarithms here, it's not wrong. However, I did learn a different method earlier in the year to make this easier. To get rid of the 3 halves power, I could take the reciprocal power. The reciprocal of 3 halves is 2/3. What I do to one side, I have to do to the other. Again, please use the full number in your calculator. Take that 6.7 number, put it to the 2/3 power. We are rounding to the nearest tenth of a mile. You get 16.6 miles. Number 4 is multiple choice. I'm going to show you as if it were not multiple choice, then I'll show you how to do it since it is a multiple choice. F of t is 2 equals 2 to the t over 3. Find the value of t such that f of t equals 32. Notice it says f of t has to be a 32. So in f of t spot, I'm going to put a 32 equals 2 to the t over 3. To solve for, to solve, I could try to find a common base, which I can. We can use the old method. 2 times 2 is 4, 8, 16. 2 to the 5th is equal to 2 to the t over 3. Once you have a common base, you can say 5 is equal to t over 3. Solve for t, you get t equals 15. That's choice C. Another way you could do it, plug your options into the t. So if I'll just show you the correct one. If you plug 15 into the equation, you'll see your answer is 32, which is what your answer would have to equal. You could try that with all 4 options, and you see the one that works is that C equals 15, and the other ones would not work. Okay, moving on to number 5. Number 5, and after an oven is turned on, its temperature is represented by the equation T equals. M is the number of minutes after the oven is turned on. T is the temperature of the oven in degrees Fahrenheit. How many minutes does it take for the oven's temperature to reach 300? Round to the nearest minute. So I'm looking for minutes. I should be able to plug in for T, which I can. It's 300. Sorry if you can hear my dog eating. He decided right now would be the best time to eat, of course. To solve this one, I had to try to get the m by itself. Very first thing I'm going to do is subtract 400. You get negative 100 is equal to negative 350 times 3.2 to the negative 0.1 m. Like we did in the very first problem, I'm going to divide by the negative 350. I'm not going to try to multiply it with the 3.2. That piece reduced on the left-hand side is 2/7 is equal to 3.2 to the negative 0.1 m power. Because I can't find a common base like I could in number 4, and the base is a number, I have to use logarithms. So it would be log of 2/7 equals negative 0.1 m log 3.2. To solve for m, divide by negative 0.1 log 3.2. Right-hand side, you're left with an m. Left-hand side, rounded to the nearest minute, is 11 minutes. And finally, number 6. The number of bacteria present in a petri dish can be modeled by the function n equals. N is the number of bacteria present in the petri dish after t hours. Using this model, determine to the nearest hundredth the number of hours it'll take for n to reach 30,700. So it tells me I want n to be 30,700. Remember, E is just a button in that calculator. It's not really a variable. I'm solving for t. To solve for t, I'll first divide by 50. When I divide by 50, I get 614. Now I can't find a common base between E and 614. I have to use logarithms, but I have to use the natural log. And the reason I have to use the natural log is because I have a base e. So taking the natural log of both sides, it's going to read ln 614 is equal to 3t ln e. And I believe we've discussed this already. ln e is just equal to 1, so you can cross it off. And really, to solve for t, all you're doing is dividing by 3. So ln 614, make sure you close parentheses there, divided by 3 to the nearest hundredth of an hour is 2.14 hours. Okay, so again, at this point, please try numbers 7, 8, 9, 10, and 11. I should see work on 7 and 11. 8, 9, 10, you don't need it. Try your best on those. And then we will work on the rest of them in class tomorrow.